How do small flaws lead to massive fatigue cracks? Have you ever wondered how tiny imperfections can cause significant failures in materials? It may seem surprising, but small flaws can indeed lead to massive fatigue cracks. Let's break down how this happens. Fatigue cracks often start at small flaws because these imperfections act as stress concentrators. This means they increase the local stress around them compared to the average stress on the material. Even the smallest defects, like microscopic surface irregularities or internal voids, create points where repeated loading causes localized deformation. Over time, this deformation builds up and can initiate microcracks. The process begins with cyclic slip. This is when dislocations, or defects in the crystal structure of the material, move back and forth under fluctuating stress. These movements create persistent slip bands near the surface or around internal flaws. These bands are zones where strain is concentrated. They can lead to surface intrusions and extrusions, which are small rough features that act like the beginnings of cracks. Once a microcrack forms, it grows with each load cycle, eventually becoming a visible fatigue crack. The journey from a small flaw to a massive fatigue crack goes through several stages: initiation, early crack growth, and stable crack propagation. The size and shape of the flaw, along with the material's microstructure and loading conditions, influence how quickly a crack grows. For instance, flaws located near the surface are more dangerous because they experience higher stress concentrations and environmental factors like corrosion, which can speed up crack initiation and growth. In metals, cyclic plastic zones develop ahead of the crack tip where slip occurs. The interaction between these zones and the microstructure of the material plays a significant role in how cracks grow. Stronger materials resist crack initiation better. However, once a crack starts, its growth depends on the local microstructure and the stresses applied. Environmental factors can also play a role in fatigue crack initiation. For example, corrosion or oxidation at flaw sites can weaken the material, making cracks start sooner and grow faster. Understanding how small flaws lead to massive fatigue cracks is essential for preventing failures. Engineers can implement design strategies to minimize flaws, such as controlling surface finish, using materials with microstructures that resist slip localization, and applying protective coatings to reduce environmental damage. Regular inspections can also help detect early cracks before they grow large. By recognizing these mechanisms, we can better predict fatigue life and avoid significant failures in mechanical components.